So strategy analysis is the beginning of a business analyst's journey or the business analysis journey. And what that means is strategy analysis occurs in the conception phase, and in that phase, the ideation takes place, coming up with the idea of an opportunity to capitalize on or a problem to solve. That's where that takes place. And we said after that, the next step is for the business analyst to, or the next business analysis step is planning. Once a need has been identified or an opportunity has been identified and concretized, as the organization has decided that indeed they are going to be pursuing that initiative, they are going to try to address that need or solve that problem, then the business analysis task of planning starts. So planning is determining the work you want to do and how you would do it and the resources that you would need. So you identify the people you want to work with, so your stakeholders, you break down your task, you estimate the time it would take, and you do other planning related activities and also plan how you'd measure success. So that happens in the planning phase. The next step we said is you begin to elicit requirements, right? After all the planning you have done, the next thing is to start collecting the actual requirements from your stakeholders. And we showed and we looked at different ways you can collect requirements from stakeholders, right? Interviews, workshop, brainstorming sessions, using prototypes or wireframes or mock-ups, using customer journey maps, different things, right? Tools that you can use in the process of eliciting requirement. And we talked about in-depthly about two types of techniques you could use to elicit requirement, one of them being interviews and another one being observations, right? And we talked about two types of observation, passive and active observation. We talked about interview question types. And we looked at all this in the context of eliciting requirements, collecting requirements from your stakeholders. Then we went into requirement lifecycle management. We said this is something you will do throughout the life cycle of your project. And what that entails is the requirements you have gathered, how would you manage them? How would you store them? How would you ensure that they are actually being implemented? And how would you ensure that what is being implemented aligns with what business said they wanted, right? So you are tracing the end and going back to the beginning to check if it's correct, and going to the beginning also to see if everything you stated in the beginning is what the contractors, what the developers are doing at the end. So we call that tracing the requirements. We said you would also be monitoring and maintaining the requirements, because the attributes, the properties of your requirements can change, or even changes in requirements may occur. But all this time, we've been talking about requirements as things or information that you would collect from stakeholders. Information that you collect from your stakeholders. And so you would document these as text. The information you are collecting may be recorded statements. So if your stakeholders allow in your brainstorming session, you can record. It may be videos, audio that you will later transcribe, you later write out as text and document in Excel or Access or SharePoint or any requirement management system that your organization uses. But in all this time, we have been talking about raw requirements. So those raw information, the stakeholder said this, the stakeholder said that. And we showed you a key example of pure requirements And one example we showed you was the requirement diary that you worked on. You did about 2 different tasks on. So you can get familiar with how a business analyst may take notes, sort of like a diary, recording all the requirements he has gathered or she has gathered, and their conversation with stakeholders. So, but those are raw requirements. The business analyst still has some processing to do on those requirements. The business analyst is not going to take those requirements or that requirement diary and just hand it off to developers. As you can see, some of the things you did was to elicit requirements from all those documentation, from all the stories, or the diary, or the raw text, raw information that the business analyst gathered. So you still did some processing. You elicited requirements, you prioritize those requirements, but it doesn't end there. The business analyst is still going to analyze the requirements he has gathered. So he's gathered all these raw information. The business analyst is going to analyze those information. And from that information, it will create a design. It will define the design of the system. So the business analyst has gathered all that information in the business analyst diary we saw. Yours may not be a diary, yours may be business analyst notes. It doesn't matter what you call it, but it's going to be something like that, right? Where you are keeping copious record, you are keeping a note. You're taking notes of what is going on and your conversation with stakeholders, and you're just writing down all those information. And the questions you had and the responses of the stakeholders and all the different stakeholders you talk to and so on. You have jotted all those things down. The business analyst now goes on to analyze and after analyzing, creating a design from those requirements. So that is a critical phase of work for a business analyst. Excuse me. So that is a critical phase of work for a business analyst. And that's what we'll be discussing today and throughout this week. How a business analyst analyzes and creates design from requirements. So some of the things we'll talk about will focus on how a business analyst specifies and models requirement, how a business analyst verifies requirement, how a business analyst validates requirements, how a business analyst defines requirement architectures or define design options, and finally, how a business analyst will analyze potential value and recommend solutions. Now, if you look at these subtopics, you immediately see that they are verbatim what the IIBA covers. So we'll be going a bit deeper than what the IIBA will cover in their chapters, especially for specifying and modeling requirements, because that is a critical activity business analysts will do. Okay, so business analysts have collected all this raw information. What is the magic they do? What exactly is the value they did? Yeah, they add, because if not, we can get anybody to just come and take notes and ask questions if that's all a business analyst needs to do. But that's not all. That's just half of the work. You have collected all this information. The business analyst needs to convert that information. Number one, make sure the information makes sense. Number two, convert it to something that developers can understand and run with. Developers can understand and develop applications with. So what we'll be discussing in requirement analysis and design definition, which is also called RAD for short, is the way a business analyst describes requirements using analytical techniques, how a business analyst ensures requirements and design are internally consistent and high quality. So how a business analyst ensures requirements and design deliver business value, how they structure requirements and design so they cohesively support the business's purpose, how they identify potential solutions, and how they recommend the solution that provides the greatest overall value to business. So these are the things involved in the specifying and modeling requirement knowledge area. Sorry, in the requirement analysis and design definition knowledge area. So it's beyond specifying modeling requirement. So let's get into specifying modeling requirement, which is the first task a business analyst will do in this knowledge area. And it is the most important task a business analyst will perform. Now, RAD, even though it is a knowledge area as far as IB is concerned, it is a phase of your end-to-end of your software development lifecycle. Who can tell me what phase RAD falls into? If you remember the software development lifecycle.
Is it design?
Exactly. Analysis and design phase.
Yeah.
Right. So it's an entire phase in your software development lifecycle. So IBA represents it as a knowledge area, meaning an area where business analysts need significant knowledge. Okay. So let's talk about how you specify model requirements. Specify modeling requirements just describes the practices for analyzing information elicited from stakeholders. So how a business analyst analyzes information they have elicited from stakeholders. The information they have elicited from stakeholders are requirements, right? Raw requirements. So how will a business analyst analyze those information? Specifying modeling requirements also entails how a business analyst creates a view of elicited requirements that can be understood from all stakeholder perspectives. There are different stakeholders that a business analyst will be dealing with, and those different stakeholders have different needs. They have different information requirements. They need different types of information about the system that is being developed. This is the phase where the business analyst will create different views, so different representations for these different stakeholders, so that all of them can get the kinds of information they need. So apart from analyzing the information to make sure it makes sense, they are also creating a view, representations for different stakeholders to make sure that everybody can understand the system that is being designed. Now we have two key stakeholders here. Two key, we can divide or categorize our stakeholders into two different categories: the business stakeholders and the tech stakeholders, right? You can look at these people, this group as playing on opposite sides of the field. They require different types of information. The information you are communicating to business may not be sufficient for the people that want to develop the system, the technical people. And the one you are communicating to the technical people may not be good enough for the people that are funding or that would use the system. right? So the business analyst in this phase, it creates representation that will inform all of them. The business analyst in this phase is also interested in creating designs, right? Not just representation of the requirements, but representations of the solution. In other words, designs are representations of the solution. Requirements are representations of the need or opportunity that a business wants to address. Design is the opposite, representation of the solution, right? So this is the phase where the business analyst creates designs, that is representations of the solution. Now, that representation of the solution is what will be provided to developers or development team, designers, your coders, and so on, right? So that they can create the solution. So the business analyst in this phase also specifies our models, activities relating to the different types of requirement they have elicited. Now, why? Why is the business analyst doing all this? Why is the business analyst doing RAD at all? Why are we even talking about RAD? Because this is where the business analyst analyzes information derived from stakeholders. This is where they synthesize all that information, that is, bring them together to make sure they make sense. Some stakeholders are saying, we want a button to turn the light on. So another set of stakeholders are saying, no, we want a button to turn the light off. The business analyst may not know this contradiction at the time of collecting information. There may be hidden contradictions that the business analyst may not even be aware of at the time of just gathering all this information, till they start analyzing the information, analyzing the requirements. That's when you start unearthing. That's when you start finding these things. Like, oh, if we do this, it will contradict what these other stakeholder wants, right? So, and in that process, the business analyst refines the information derived from stakeholders. If it means they have to consult the stakeholders, have another meeting, and adjust the requirements to make sure that there are no contradictions. Okay, so even besides contradictions, this is the point where the business analyst analyzes all the information, synthesizes them, make sure they represent the business need and they make sense in terms of, are they informing us of the solution we want to develop? Can we get a clear-cut solution from them? And so the business analyst refines these raw requirements that they have derived from stakeholders. There are three ways business analysts can represent requirements, raw requirements they have gathered from stakeholders. One of them is pure textual way. So textual representation as text. And this is an example. This is actually a real requirement from a system that we're currently developing. And you can see the requirements stated here and numbered appropriately. Right? So you can have situations like this where a BA represents requirements as pure text. Another way business analysts represent requirements is as matrices, tables. Now you may wonder, why am I not going into details of what this means, what this means? These are not standards. They are not standard. They are just our own vision for how we want to structure the requirement. The key thing you should take note of here is the requirement is represented as pure text. So some people may just write the requirements, and as long as they have a number for it, the attributes of the requirement you put here will depend on you and what you are trying to record, right? What you are trying to keep record of. In this case, we're trying to keep record of whether it's something we're doing now or later, the progress, whether it's ready to be tested, material, implementation, that is specification of what the person should do to implement it, and test, whether it has passed test 1 or not. That is the first test we did, or whether it failed, whether the developer was not able to meet the requirement. This is not a standard. This is just something that was created on the fly, okay, based on our need. So the key thing is requirement was represented as text, raw text, no standard. Okay, we collected requirement from developers, from stakeholders, business stakeholders, and we summarized them, right, based on what the stakeholders want. And that's it. So all these columns you see were just added as needed, as we thought we needed. Okay. So if you ever have to represent requirements as text, your environment and your needs will determine what you put in the matrix, in the table, or if you're even using table, or if it's a Word file, right? The information you need to monitor will determine what else you collect or you make available to developers. So there's no standard for this one. Another way stakeholders can, or a business analyst rather, can represent requirement is using a matrix. And we have talked about this matrix thing for a while now, right? I showed you a requirement traceability matrix using Access. We've mentioned that you can do the same with Excel. So that's another way a BA can represent requirements. You can store requirement in a tabular format with a clear structure, showing maybe the stakeholders that requested them, right? And the what's it called now? The particular requirements that should be carried out, right? So again, this representing requirements in a matrix just means putting requirements in a table. You want to put it in a way that is logical, that makes sense, right? So that you are not repeating the requirements, or it's easy for those who see it to understand it, right? That's the key thing when it comes to putting it in a table. Is this typical? Is this something that you ordinarily do, or is this a focus? No, it is not. It's not typical that, except maybe in your requirement traceability matrix, where you just want to be able to trace requirements. Yes, then normally you would use a table. Or would you present requirements in a table to developers? That would be unusual in this day and age, right? But it is important that you know that it can be done. You can actually present your requirements in what's it called, tabular format, so as a matrix, and put attributes of the requirement in the column, and what's it called, the specific requirements in the rows. Now, the main way to represent requirement we're interested in and will be going deeply into is using models. Anywhere you see models, you can replace that with diagrams. So drawings, diagram means the same thing in the business analysis space. Okay. Now, let me take one step back to mention something before I move on. So I showed you this as a way to represent requirements as text. Representing requirement as text is not uncommon even today. It most likely will not be in this form, but I just want to mention that in an organization using the agile approach, which we will still get into in greater detail later, many times you will take raw requirements and convert them into user stories and acceptance criteria. So in agile or in agile environments, you take the raw requirements and you convert them into user stories and acceptance criteria. And these two are text, they are pure text representation of requirements, but they have a method to them. They have a formula for writing them. And so you follow that formula and you structure your requirements in the way that is prescribed, and developers can usually understand it and run with it. So textual format of writing requirement has not died. If anything, it is living and it is strong. Okay. But for the traditional model, which is what this one is, textual format is going down, right? It is going down. Just representing requirements like this is going down, moving towards more agile representation or agile approaches. Okay. So the key part or the key type of requirement representation that business analysts should know and be aware of, and is a core skill. A core skill of a business analyst is modeling. Modeling. And I've said modeling is the same as saying drawing or diagram. Drawing. Okay. So quick recap, 3 ways to represent requirement as text, in tabular format as matrices, or you use models. Models meaning drawing. Now, the advantage of drawing is with textual representation of requirement or with matrices, you are assuming that the stakeholders speak the same language as the BA, right? So the format for writing user story is a format specified in English. You're assuming that the developers speak English. But you see, with models, which are diagrams, regardless of the mother tongue, regardless of the mother tongue of the developers or stakeholders, everyone that understands the modeling language can understand the model. So representing your requirements using diagrams, anyone that understands the diagram can implement it, or at least understand what you are trying to inform them of. Just like a fashion designer will use sketches, right? A tailor fashion designer will use sketches to represent how they want the clothes to look like or the tailoring to look like. And any tailor, even whether they're speaking broken English or Queen's English or whether no English, as long as they can understand the sketches, they can create. We expect that they should be able to create the clothes, whether they are foreigners that have never spoken English before. If they understand the sketches, they should be able to create the design in terms of clothes. That's the same way modeling is to a business analyst. Okay. So it's diagrams that represent how you want a system to be designed, or diagrams used to design a system, used to show the design of a system. And developers can implement these models, these diagrams. So we'll talk about several different modeling techniques. One of them, one modeling technique we'll be talking about is called the context diagram. The context diagram. This is a high-level diagram, or put in another way, this diagram is used to show high-level details of your system. High-level details of your system. So it's not showing the granular details. It's just like you flying in an airplane, looking down at your system. You can't see the particulars. You can't see the intricate information, the internal workings of the system. You can only see the system from very high in the sky. So that's what a context diagram does. It represents your system with this bird's eye view, this 10,000-foot view. And the goal of context diagram is definitely not to show the inner workings of your system. The context diagram does not want to show the inner workings of your system. Instead, the focus of a context diagram is to show the external entities interacting with your system and some messages that they pass to your system. So a context diagram is intended to show external entities interacting with your system and the message that is being passed between your system and those external entities. So that kind of diagram will help you show the scope of your solution or of your system. The scope, meaning what your system will affect and what will affect your system, sort of the boundaries, right? What will impact your system and what your system will impact. But it's not showing the internal workings of the system. This kind of diagram is useful when you are communicating, say, with C-suite executive, or you are just discussing high-level information with your stakeholders about maybe the kinds of information you will need, the kinds of entities, people, organizations that your system interacts with. Okay. So this is an example of the context diagram. Now, look at this context diagram for an email server information system. So this is the system that is being developed. These are external entities. So the rule for context diagram, the system will be drawn, the system that is being developed will be drawn as a circle. Then external entities will be represented using squares. So this is an external entity, this is another external entity, and this is the core system being developed. Then you have arrows showing the message flowing between systems. Okay, so these are the three components of your context diagram. It's basically the simplest modeling technique to use because it only has three components: your squares, circle, and arrows. Three components to create the model. Now, what does this diagram tell us? The diagram is telling us that this email server information system that we want to create will interact with two entities, a user and a recipient. So the user of the system will provide these types of information, or these are the types of messages that will pass into the system: their email address, password, and the message they want to send. And once they pass that into the email server system, the email server system will send the message to a recipient and send confirmation email to the user, to the sender. So it's showing just the basics of how the system will work and how it will interact with external entities. So now we know that the focus of this person's design is an email server information system that will allow sending of message from a user to a recipient. So nothing else. This is also useful in helping us, as I mentioned, scope our system, because now we can even put some things outside. So if you put an entity outside this box, outside this container that I just drew, this is the container. So if you put this outside and you say user recipient, let's say who else can be using the email server? Let's say marketing or advertisers. What you are saying is this system we are developing only caters to is an email server information system that will cater to users and recipients, but will have nothing to do with advertisers. So advertisers are outside our system. Okay. Okay. So this is the simplest modeling language you can use. Now, this is useful for C-suite executives. You want to quickly show them the external entities that will interact with your system and just briefly how your system will work without showing them the details. You see, no details here. Without showing them the details of the system. So there's no detail of how the email server information system will work. But we're just telling them summary or no details of the components of this email server system. So we don't know what goes into it, but you are just telling them that. So with the system we are developing, this email server will be able to send messages to a recipient. And when the user enters the message, and the email server will take their email and password and send the message, and it will send confirmation. So you are not bothering them with the details of what is inside this email server system. And they too, they are not necessarily interested in knowing because it may not even be their area of specialization. Okay, so your C-suite executive just want to know what the system will do based on their own level of understanding of the system, right? They know they have a business need. And for example, you're saying there's going to be a website that will solve their problem and the website will do this and that. They just want to know. So who will interact with the website? Maybe customers will be able to buy and sell through the website, and bank will keep the money, something like that. And you can show the external entities interacting with the website without going into details of what the website will have. It will have a payment gateway. It will have an about us page and 300 other pages. You don't want to bog your C-suite executive with all those details. That's none of their business. They just want to know that there is a website and he's going to interact with customers this way, and he's going to send money to the bank this way and do some other things. Right? So this very high level detail. I like calling it a 10,000 foot view, right? You are in the plane with all the requirements you have gathered. You're in the plane with the requirement and you're trying to land that plane. And when you land it, that means you have landed it in tech, design, developers in the level they can understand. But in that height, is C-suite executives that can come and meet you there, right, and understand what you are talking about. So no details in this space. So let's see another type of modeling technique we would use, right? Remember, like I said, we're trying to land a plane here, a plane of requirements. And when we land it, it means we have dropped it down in a way that your developers can understand and implement. So the first one is 10,000 foot view. We're still coming down. That 10,000 foot view is for your C-suite executives and business leaders to get the gist without bothering about details. So the next step is your mind map. Now, because I mentioned mind map here does not mean mind map is the only technique you can use to further break down your requirements. Remember, this concept map does not give us any detail of the system. So we want to get more detail, maybe for another level of stakeholders, maybe our project managers, our mid-level managers, right? So that they can understand what the system is about. Mind map is not the only way to do it. Neither is context diagram necessarily the only way to do this summarized view. But context diagram will be one of the major ways, standard ways. But you could also use what is called a concept diagram and just represent some of these as concepts. So that has a different set of rules and so on. But I'm just emphasizing so you know that maybe in future, as you continue to develop as a BA, if you find that modeling is something you use a lot, you may decide to freestyle, learn some more techniques, and even swap out some of these techniques for another technique you like, just to add variety to your arsenal, right? So, but we have gone from a very summarized view and we want to add more detail. Mind maps are good for that. Mind maps are originally designed to help you map out how someone is thinking, right? How human minds process information. They are very good when you are eliciting requirements because you can be mapping out the relationship between what your stakeholders are saying, and it will be prompting them to give you to think more and to give you more information. But that's not what we are using it for here. We're assuming, of course, in this case, you have finished eliciting requirements and you want to represent those requirements. You want to analyze those requirements so that even you can understand them better and you can see the relationship between them. So we're not using it as a tool to generate requirements. We're using it as a tool to visualize, to represent requirements. So that's a different use. So mind map is used to generate new ideas, typically. It assists in conducting a deep dive of existing concepts. It facilitates the creative and critical thinking about a specific problem. It can create an overview or summary of complex ideas or problems. This is what we want to use it for. You see all these other uses, 1, 2, 3, they are good when you are eliciting requirements. So mind map can be used for different things. They're good for your brainstorming sessions and all those types of workshops. But we want to use it to summarize all the complex information we have collected so we can see the relationship between them. So let's see an example. This person, for example, is planning their 2022. They can say, okay, 2022 that we're planning. My concerns for 2022 or my major focus will be on saving money, health, career, fun, mind, family, and friends. So under save money, they can have branches and other nodes. So their plans under save money will be increase contribution 401k, create another income stream. Their plan under health may be eat less carb, run 4 to 5 times a week, get at least 7 hours of sleep, renew gym membership, right? And so on. So this is a mind map showing somebody's breakdown of their vision for 2022, the things they want to do, and the specific details of those things. That's how you use a mind map. So you can use it when thinking. Imagine you are the one thinking about your 2023. You can come up with topics like this. So the main topic, subtopic, and subtopics, right? Or main idea, sub ideas, and sub ideas. And these can even have branches too. It can have its own branches going on and on, right? So this can be something you do when you are thinking and you're trying to plan out your year. It could also be what you do after you already have all this information. And that's the way we want to use it here. The business analyst already has all this information in a business analyst diary or a note that they have taken. And then we can look at that note and start mapping the information we are getting. Right? So what are the key concerns? Billing, food, right? And you start mapping what are the things under food, this and that. What are the things under billing, this and that, right? So that's the way you would use mind map at this phase. Now, this is IBA's suggested structure of a mind map, and I will show you their rules concerning how you should draw a mind map. So these rules are guidelines. No one is going to arrest you for not following them, right? They are just IBA's guidelines, and people have been using mind map before IBA even started or existed. So they are just looking for a way to make everything a bit uniform, to standardize things. It's not a must that you follow them. So, but the general idea is that you have a main topic in the middle, and then the topics are linked. So these branches or pathways will have keywords. Then you have topic one, keyword, subtopic, and you can go on to other subtopics. Right? So that is their structure, that the main topic you want to deal with will be in the middle of your mind map. So let's see how a business analyst would use this to represent a system that they are developing. So this is a website, digital humanities website. And this is how these business analysts used it. So you create, this is the main topic. These are subtopics. So it will have homepage, about us, news and events, stay connected, impact, resources, people, and projects. Then these are subtopics. Under projects, they have religion, philosophy, anthropology, library, AIST, English and literature, and so on. Under people, you have external project leads / teams, tech, resources. All right. So you see how they use the mind map to represent all aspects of the website they want to create. And they're creating a website. So they use a mind map to represent all aspects of the website. So the features of the website, the pages it should have. And they organize these pages in this way, even color coding it. So they use colors. So you once you see yellow, you know that has to do with projects, and these are the pages on that project. So maybe they collected all these requirements where people told them, we want a religion page, we want a philosophy page, we want this. And the BA says, so those things, religion, philosophy, what exactly are those? Those are different projects we are working on. BA noted them. The BA noted them, right? Then maybe homepage. We want a slideshow, this, that. The BA noted them. And the BA is able to group all this together, group all these subtopics or sub ideas or sub requirements together into one major requirement. That okay, so all these will go into our home page. All these will go into our about us page. From all the things these stakeholders are saying, the about us page should be able to cover all these requirements they have given. And so the BA is using mind map to represent the information they have collected, the requirements they have collected. And this helps the BA organize this requirement. So just even thinking about what should go into the project page involves, as I've said, some thinking, right? So you see, the BA must have thought, okay, this and this and this, maybe from the information he collected, okay, all these will be in project page. So he's analyzing the requirement and representing them well. So now they can go ahead, if they present this to developers, developers can know that teaching T&P, research, our integration, all these should be in a page called impact, or should be accessible for an impact page, or should all be contained in the impact page. Right? So the BA has designed the system through this model. The developer can now implement following this model. Now, your mind map is not necessarily geared towards developers. It's not expected that you would send your mind map to developers. It may be one of the documents that will make up your requirement and design architecture, which we'll get to. So maybe it's going to be one of the documents in your design portfolio, so people can see it. But it's not necessarily going to be what you'll be sending out to a developer. This will be useful to maybe your project manager or that BAs. They can see all the things that need to be done, right? All the different parts of the project. And who knows, you may even be able to assign different developers or different BAs to the different aspects of this thing now and plan for each one separately. Right? So this may be useful for planning and management purpose. But what this helps you do is it gives you details of all the components that your system should have. Unlike the context diagram that just summarizes the whole system here. This one is breaking the system down to tell you the different parts of the system. Okay, so you see, these modeling techniques gives you another view of the system that the first one does not give you. So that's why usually you use all these techniques together. You use context diagram because of what context diagram can give to you, and you use mind map because of what mind map can give to you. Okay, so let's continue and see the components of your mind map. So your mind map will typically have branches. Those are the links between nodes. So maybe your main idea and then your other ideas, right? Then sub idea. So it could also be main topic, then normal topic, then subtopic, right? So this is your branch. So your branch is an association line between main topics, topics, and subtopics. The line is typically where the keyword is located that describes the nature of the association, right? So you would usually put a keyword here to describe the nature of the association. This one does not necessarily have a keyword telling us what these things mean, right? Maybe if he says something like part of, but they didn't say anything, which is fine. But if you are following IBA standard, it's expected that there will be a keyword between the topics. Right. So even in this example, there's no keyword between the topics. But that would be ideal. So we know the type of relationship. Right. So looking at this now, we don't know if all this teaching T&P research should be inside impact or should be accessible from impact. Maybe there's an impact page and all these will now be links at teaching T&P will now be accessible as other pages from impact. Or we have an impact page and it's divided and there's teaching here and there's T&P here. we don't know the type of relationship because it's not explained. So you see, that's why IBA is giving these specification, these guidelines that you should label the branches so we know the type of relationship that will exist between two components of your mind map. Then IBA suggests that the keywords, that means your main topic, topic, and subtopic, should be single words. I usually laugh at this requirement. So they said it should be single words, and it should articulate the nature of the association of topic or subtopic to the main topic. Single words. Look at this one. This is home page, about us, news and event, resources, people, projects, stay connected. So indeed, some are single words, some are not. Right. Look at all these ones, plenty words. Some of these rules, they are not easy to follow. And so this is not a place to, this is not a hill to die on, right? Don't focus too much on following. Just take the good things from their recommendation and use them when you can. Even why I laugh is that even mind map is 2 words, right? The name of the technique self is 2 words. So saying that people should make everything single word may not be realistic. Even they here had to write 2 words, main topic. Then color. Color can be used to categorize or prioritize and analyze concepts, right? So colors are your friend when it comes to mind map, when it makes sense. Don't just put color anyhow that the color will not have meaning, right? So use colors in a way that makes sense, that will be able to understand that you are trying to show us different categories of things. See career, pink, or the underlining pink. Or I think it's pink, it may be yellow. You people that are better at colors would know. Anyways, the gist is because of the different color, we can easily see that this is a different category of things from fawn, which is like purple or indigo or violet. I'm sure someone knows. So then you have images. So mind maps allow you enter or add images, right? And images would help even people quickly understand what you're trying to represent, right? So imagine if you could put an image here now, right, in your mind map to represent projects. So we can immediately see the image and know rather than just text. As they say, a picture is better than 1,000 words. So what are the strengths of mind mapping? Mind maps allow effective collaboration and communication. It's good for summarizing complex ideas, and it facilitates stakeholder understanding and decision making. Mind maps enable creative problem solving and help in preparing and delivering presentations. Okay, so these are the key strengths of your mind maps. They are great for presentation. People can see a lot of information at once in a way that makes sense because you have color coded them, you have categorized them, right? So they are summarized. People can immediately see the connections, even if you don't explain the connections well, like in this case, right? Or here, in this case, where there were no particular explanations for connections, people can still make sense and say, okay, all this is what this person wants to do concerning their career. All this is what they want to do concerning their health. All right. So that's one very key advantage of mind maps. It's easy for people to understand. Now, some limitations, though, are as an informal exercise, communicating the resulting information to relevant stakeholders may prove difficult in certain situations. Okay. So communicating the information that you have in your mind map to stakeholders may be difficult in some situations. Maybe the information is too much. Context diagram helps you in that case. They want to see simplified information. They don't know what all these other plenty things are and what that one has to do with their project, right? So those are things to consider. Since mind map is primarily used for brainstorming, bringing out a mind map, people may think you want to do a brainstorming exercise. So that's one downside. People may think it's brainstorming until you say, no, 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 no. I'm not brainstorming. I just wanted to show you the summary and relationship between the different parts of the system that we're developing. So sharing the ultimate result of a mind map may prove difficult to communicate to those not involved in the exercise. Again, who are those that are likely not to be involved in the exercise? Right? There will be those very high level stakeholders that are not bothered by the details. So in that case, providing them with mind map may just be a burden, may just be burdensome because all those details they don't care about, or it's not their cup of tea. Then, but mind maps, in my view, brings the system closer to development. Again, we're trying to land a plane. So we started from this 10,000 foot view. Mind map brings it to about 5,000 foot. You are still not seeing the inner working of the system, but you can see the components. It's beginning to take shape. You can see the different parts of the system. You don't know how they are working yet. You don't know who is doing what or what is even going on, but you can see the different components. Right? So we take it a step further then. Now we want to get closer to the system. We want to land the plane and start developing at ground level where we can see ourselves. Everybody can see what is going on in the system and how the system is working. Well, as it turns out, there are several techniques to do that. One technique will not do it. So we're learning a group of techniques called or modeled with what we call the unified modeling language. So unified modeling language is a standardized modeling language used to visually represent architecture, design, and implementation of software systems. Architecture, design, and implementation of software systems. The key gist is, you see, the unified modeling language or UML. Some people, they'll ask them in interview, what's the meaning of UML? They don't know. UML is something you should know, unified modeling language, memorize it. UML is used to represent the structure and behavior of a system. Like I said, not just one technique to bring your system to land the requirement. It's not just one technique. This last phase of landing it, there are many techniques that will come into play. UML is a unified modeling language consisting of many modeling languages or many techniques, not one, many techniques. So we'll see them now. Some of those techniques help represent the structure of the system, meaning how the components of the system and how they relate to one another, right? The components of the system and how they relate to one another. So that's what some UML will help you do, some of the techniques under UML. Some others represent the behavior of the system. So they help you visualize how the system behaves and interacts with itself, with users, with other systems, and other entities. So how the system behaves in total, they help you represent it. So you have techniques in UML that represent structure, that is the organization of the system. Then you have techniques that represent the behavior of the system in greater detail. So you need these two in order to communicate the design of the system to tech. the design of the system, to tech. You need these two. So before we go on, though, I want to mention that although I've been talking about modeling, and modeling is interesting and is a core area of business analysis, and like we've said, modeling, specifying and modeling requirements will help you in analyzing the requirements, seeing the relationship between them, and understanding your requirements better. In some environments, you may hardly model. You may not need to model. Modeling was is still an essential skill. It's still a good skill to have, right? Good to have. But if you are working in an agile environment, like you have heard some of our instructors say here, even I remember Shagun saying that for the first 9 months on the job, he never modeled. I think he modeled, but he was mainly doing user stories. I remember I modeled because there was a time that I had to get involved. But I know he was mainly doing user stories. User stories. So depending on your environment, like in an agile environment, for example, it may be mainly user stories, right? And acceptance criteria. So textual representation of requirements following the agile format, which we'll talk about later. But in the off chance that you may be responsible for representing something or explaining something, this is a good skill to have, even if you're in the agile environment. Many times, just even modeling the requirement to further explain what you are trying to get people to work on may put you on top, right? Would cause your stakeholders to give you another look, to give you a second look, to know that this person is a professional pro. So it's not just a pro, it's a pro, a pro, senior pro level, right? Even though they don't need it, like when you are explaining something or you are documenting something in the agile space, which is not frequent or is not as frequent as you'd have in the traditional environment, if you throw in a model there to further explain what you're saying and how things are moving, like, yes, this person is, we did not make a mistake in hiring this one. This one is an asset to us, because these are things that many people are not strong at. You have business. I remember I invited a business analyst of maybe 15, 16 years, and this is not to shame anybody. A business analyst of 15, 16 years, I invited her to join in modeling something, and she humbly denied the invitation, saying, sorry, it's not my strong suit. Right. So, and I've had a vice president of design, I've worked and had chats with that kind of person, and they showed me what they are doing in terms of their modeling, and they mentioned that there's their knowledge of modeling is limited, but the little they know, they're using it to make money and get good positions. So modeling is a very, very good skill to have. So like I mentioned, there are several techniques under UML. UML is not one technique, but you can categorize these techniques into techniques that help you model the structure of your system and techniques that help you model the behavior of your system. So some of these techniques for structure will include class diagram, which is the one we will focus on. The ones for behavior, activity diagram, use case diagram, will deal with those, right? Then, if time permits, while looking at activity diagram, we may dabble into some other modeling techniques that are outside UML, but that can do what you can do with your activity diagram. Now, so I've talked about, I've mentioned activity diagram. What is activity diagram? Activity diagram. Let me put this in a box because this is not behavioral, this is structural. Activity diagram is a graphical representation of workflows or stepwise activities and actions with support for choice, iteration, and concurrency. All this big English just means activity diagrams help you model the end-to-end process of a use case, of a task, something you want to do that is valuable to business. So where does it start from and where does it end? So what activities will be performed to achieve this thing? For example, say you want to withdraw cash from an ATM. What are the steps you would need to take to achieve it? Right? You can use an activity diagram to represent those steps. Then you have a use case diagram, which is another technique we'll be looking at. A use case diagram describes a system's functional requirements in terms of use cases. So it's representing the functional requirements of a system as use cases. Remember, functional requirements are the things the system will do, the things the system needs to do, the functionalities of the system. So it represents those as use cases that enable you to relate what you need from a system to how the system delivers those needs. So it's representing functional requirements as use cases. What does that mean? A use case is a way a user would use the system. What are some of the things users can do with this system? Those are the functionalities of the system, right? But those are also the use cases. For example, an ATM, what is one thing you can do with an ATM? You can withdraw cash. So withdraw cash is a use case. Okay. So it represents functionality of systems or functional requirements in terms of the ways a user would use the system or what a user would use the system for. Then I'll skip sequence diagram since we will not be doing that. And I'll go to class diagrams. So class diagrams show a set of classes, interfaces, and collaborations collaborations and their relationships, typically found in modeling object-oriented systems. Bottom line, a class diagram represents the components of a system, showing their properties and what those components do. So it represents the components of a system, showing the properties of those components and what the components will do, and the relationship between the components. So that's what class diagram does. And that's why it's the number one diagram used to represent structure of a system, even to the programming level. In fact, if you know class diagrams to the extreme, you can create class diagram for a system, and some systems will generate the code, the programs, the code for them. You will just be drawing, and there are systems like Visual Basic and some other ones that will be generating code based on the class diagram you are drawing. So class diagram is used to represent the components of a system, the relationship between those components, and the properties of the component, and what the components will do. So these diagrams or these modeling techniques we have chosen out of the plenty UML techniques we have are the key modeling techniques used in UML. The number one modeling technique used in UML is use case, followed by class diagram, followed by activity or sequence diagram. All the others are hardly used. And so that's why we are focusing on these diagrams. So as we begin to round off today's discussion, I mentioned that one way to represent requirements is using text, textual format. Then I said another way is using matrices, and the last way is using models. We've started talking about models and the different types of models we will learn. We won't get started on, we will start proper modeling tomorrow, as we'll look at one or two of the modeling techniques. Oh, we already looked at context diagram and mind maps. So yeah, we'll get to use some of those this week, and we'll start use case diagrams and the other modeling techniques this week too, most likely tomorrow. But I mentioned that in the agile environment, your raw requirements are converted into user stories. And I said these user stories have a format to them. They are text, but they are not just anyhow text. They have a specific format. This is the format. So a user story is a requirement told from the perspective of a user. You are writing the requirement from the perspective of the stakeholder that needs the requirement. Okay. In this example of a user story, let's assume a job seeker has this requirement. So we'll write the requirement from the perspective of the job seeker. As a job seeker, I want to post my resume on the job portal so employers can find me. So that's the job seeker's requirement. So in this requirement, in this user story, this simple sentence, I'm mentioning who, that is the stakeholder, what they want, that is the functional requirement, and why they want it, the business requirement. Who, the stakeholder, so stakeholder requirement. What, the functional requirement, and why, the business requirement. Who can remind me of the different types of requirements I said we have? Please unmute and remind me of the different types of requirement we have.
Functional and non-functional, if I remember. No. Okay.
How about Wale? Is Wale there?
Yes, I'm here.
Okay. What are the types of requirement we have?
That's also what I remember. The functional and non-functional.
Laura,
Is it extra? Okay, sorry.
what are the types of requirement we have?
Stakeholder requirements, solution requirements. Under
Okay.
solution, we have the functional and non-functional.
So stakeholder requirement. You are still missing one or
Business.
two. Okay, it starts from business requirement to stakeholder
Transition
requirement. Okay, so now we are remembering to solution requirement, and solution requirement are of two types: functional and non-functional requirement. On the side is where you have transition requirement. Do we remember now?
Yes, sir.
Okay, thank you. Now, from these requirements, you can see that this simple one-line sentence, as a job seeker, I want to post my resume on the job portal so employees can find me, represents these three requirements: stakeholder requirement, business requirement, and part of the solution requirement, because it only represents the functional requirement. But solution requirement has functional and non-functional. So this user story that Agile uses contains 2.5 of our requirements. And that's one of the powers of Agile. It looks simple, but it has power. So people using Agile may not need to model anything. Usually they don't need to model or send models to developers. They can just send this user story and the developers will know what to do. Okay. From this alone, you can trace the requirements. You know the business requirements that is being fulfilled. You know the functional requirements. You know the stakeholder that is requesting it. So Agile has power. This simple one sentence story has a lot of power. Now you say, okay, we have the functional requirements. What? But that's just half of the solution requirement. What about the second half? The second half is, for every user story you write, you must write an acceptance criteria. For every user story, you must write an acceptance criteria. So acceptance criteria refers to the set of predefined requirements that must be met to mark a user story as complete. So what are the requirements that the functional requirements must meet for us to say you have done well, you have done them well? Meaning, how should those things function? So functional requirement tells us what should be done. Non-functional requirements tell us how those things should be done, how they should behave. So your acceptance criteria is the one that gives us the information for how the functional requirements should behave. So an example would be this. We're saying a job seeker, I want to post my resume. Okay, acceptance criteria will include the information that should be collected from the user to allow them post their resume, where the information should be stored, and if the user would need to pay, this is where you would put all those requirements for how this posting of resume should occur, how this function should occur. So a user story, and we'll go into this in greater detail when we get to Agile. But a user story for getting coffee, let's assume that tonight I'm especially tired for some reason and I need a cup of coffee so that I can teach tonight. Who can form a user story for the coffee request? Now, this is the format of a user story, so you have to use this format. You put the who as a dash, I want dash, so that dash. We're waiting on mute. Form a user story for the coffee request. Winifred, you haven't spoken.
Let me just try directly. So, as a teacher, I want a cup of coffee so so that I would not, so that I will be awake and be able to teach.
Okay. As a teacher, I want a cup of coffee so I can stay awake to teach. Good. Now, imagine if, as Wale is coming to the class tonight, I say, Wale, please help me get a cup of coffee. I give him that user story, but I don't give him an acceptance criteria. How will he know how I want my coffee? So if I just say, as a teacher, I need a cup of coffee so I can stay awake at night, and I pass him the user story without my acceptance criteria of that coffee, no sugar, no cream, just black, right? How will he know? So Wale may go ahead and buy the coffee the way he thinks I would like it, and that coffee may end up falling flat, may fail because no acceptance criteria. So you see, you cannot provide user stories without an acceptance criteria. The user story is just half of the story. The acceptance criteria is the second half. Just like your functional requirement is just half of the requirement. Your non-functional requirement is the second half. Okay? Any question? Okay, so this is a good point to round off and stop. So let me summarize. We are specifying our modeling requirements. There are 3 ways to go about this. You can use text. In the traditional approach, just any summarized clean text will do, following invest or the attributes of good requirements that we've learned. In the agile setup, your textual requirement will be represented as user stories and acceptance criteria. The great thing about that is that that may be sufficient for you to send to developers and develop your product. That is usually sufficient. You don't need any modeling. You don't necessarily need to do anything else. Just elicit your requirements well, convert them into user stories and acceptance criteria, and send them off to development. In a good environment, you have designers, people that will create models. Not models now. Yeah, they are models, but they don't call them models. People that will create prototypes. So mock-ups, wireframes, and normal prototypes to support your user story if there is a need for it. If there's a need for it. And your developers, with all this, with your user story and possibly mock-ups or wireframe, they can create anything you want them to create. They can develop anything you want them to develop. But when you are working in an hybrid environment or a traditional environment, textual requirements may not be sufficient. You may need to go forward and model these requirements. Either ways, learning modeling is a good skill. So you can represent requirements as text, as matrices or tables, and as models. Any questions? Any question?
The only question I have is probably not related to this. It's just a side note question.